Elliot, this is easy. An ellipse is an oval. You got the chapter. You're good. Okay. So, and an oval is a circle that's kind of been pulled one way or flattened one way. Exactly. So if you think about a circle's structure, x squared plus y squared equals 25. That would be a circle, right, centered at 0, 0 with a radius of 5. Yes? Then we started to see in geometry and in algebra 2, you would see like, okay, well, what do you know about this circle? So the center here, this has been shifted right 3 and down 2. So the center on this one is 3, -2, still a radius of 5. Okay? The thing about circles, though, is that the coefficient on the x squareds and y squareds is always 1, right? And then it equals the radius squared. With ellipses, the structure is going to be always that whatever it is equals 1. So you would never have it equal 25. You would divide every term by 25, and it would be x squared over 25 plus y squared over 25 equals 1. I mean, this is still the same circle, but with ellipses, it's going to equal 1, but these numbers won't be the same. This number is going to tell you how far it's pulled, like 5, the square root of that number, is going to tell you that it's kind of pulled 5 units in the x direction, which is left and right, and the y squared denominator is going to tell you that it's pulled 5 units also in the north-south direction. So if it's pulled 5 in each direction, it's perfectly symmetrical and it's a circle. But these numbers will typically be different. So it'll be pulled further horizontally, like if that was a 36. It would be pulled 6 units in the x direction and only 5 units in the y direction, and so you'd be left with this oval that's oblong horizontally. If you pulled it more, if this was like a 100 underneath the y squared, it would be pulled 10 units kind of north-south, and only, if we keep that at 25, only 5 units, you know, left-right, so it would be oblong vertically. Does that make sense? I think 10 on each side, kind of. But don't go, that's just the concept I'm talking about. I'm not getting into total specifics yet. But that's really the jump between a circle, which is very symmetrical and pulled from the center equally, both left, right, and up, down, versus an ellipse, you're going to find it's pulled differently. Okie doke. So she got right into all of the details right here. So the definition, the ellipse is a set of points such that the sum of the distances from two fixed points is a constant. That's the definition. You're probably never going to tap into it. Here's what that means. So all of these points that make up the ellipse, the sum of each, if I just even took this random one, the sum of this of the distances from this to two fixed points, those fixed points are called focuses, foci. You've seen focuses with parabolas, right? And that is technically a conic section, as is a circle. But the fixed point are the focal points, which are here and here. So there's the center of the ellipse, but your focal points are here. So when you take the distance from any point on the ellipse to one of those focuses, and then add it with the distance from that point to the other focus, that's going to be the same value no matter where you are on the ellipse. So the point that she shows right here, no, she doesn't actually show it. This top point, that distance from here to the first focus plus the distance from here to the second focus, when you add those together, it'll be the same as this one that I just drew. So look what happens when I pull this point down. This length just got longer or shorter? Longer. And this length just got shorter. and it actually made up for the difference of the other one so that they're always adding to that same number. Does that make sense? And then if you pull it down here, I mean, here to the first focus got even longer, and here to the second focus got even shorter. So one of them is growing as you kind of work around the circle, and one of them is shrinking, but the sum of the two of them is still all hitting the same number. Capiche? All right, so that's the definition of what these points actually do. Like the definition of a circle, technically, is the circle is the set of points such that the distance to the center is the same for all of the points. Okay? And the ellipse makes it a little bit more complex. So these are called, that's a focus 1, that's focus 2. And they're kind of equidistant from the center of the ellipse. You have, then she talks about the foci, that's just focus 12. The fixed point F, she used subscripts, F and F prime. Well, she's calling one focus F and the other focus F prime, so we can just follow and use that notation. The one is to the left of the center, the one is to the right of the center. The point is this distance C is the distance from the center to a focus. So however far away the center is from your focus, and it should be the same to either one, we're going to call that C. Okay? So when C comes up. The center, we know what that is. The axis. So the axis of a focus is, or the axis of an ellipse rather, is just the line that goes through the focus. So if we had a vertically oblong ellipse, the axis would go the longer way. And the center would be here, and focus 1 would be up here, and focus 2 would be down here. Kind of depends on which way it's stretched. But the foci points are the long way. Correct. Okay, so they're pulled whichever the long way is. So back to this axis. There's a major axis, that's the major, that's the long way. And then a minor axis, which I don't believe we talk too much about, goes the short way. Okie doke? So major versus minor. Major goes along the longer side. Yeah, it's true for the major, and we talk about the major most often, I think is probably why it's like that. Yeah, she probably shouldn't even have that, to be honest, because there's two separate ones. Vertices, the intersection of the ellipse with its axis. Here's your ellipse. Here's its axis. Okay, so these are your vertices. Again, the long-most endpoints, so way up here or way down here. So here's your two structures. And to me, they're kind of the same thing. They're just a little bit switched with where A is and B is. And I think, honestly, all of what I'm doing right now, giving you these arbitrary letters and so forth, makes it way more confusing than you're going to find it once we jump into an example. But A is always bigger than B. She doesn't write that here, but A is always bigger than B. If the bigger number is underneath the X binomial, then it's stretched horizontally. It's an ellipse that's stretched horizontally. And if the bigger number is under the Y binomial, it's stretched vertically. It's really the point I got at up here. Like if this was a 100 versus this being a 25, it's being stretched more vertically because the bigger number is under the Y, which should make sense because the Y-axis is the vertical axis. If the bigger number is under the X-axis, it's just getting stretched horizontally. Okie doke. And then we will use that. I'll wait to come back to that when we need it. And then to sketch, what did she say? To sketch an ellipse more accurately, find the latus rectum, the chord perpendicular to the major axis through its focus. Length of LR. All right, we'll get to that when we get to that. Okay. This is going to be so much easier for us when we just jump into an example. Is that really dark? 3, 2. Is everyone good with that? Yes. So if I sketch a graph, and I'm going to plot the point 1, 2, 3, 1, 2. The center is 3, 2. Got it. Okay. Now, which way is this going to be stretched further? The x or the y? The x. And it's going to be stretched how many units? If that's a squared, what's a? 2. So a equals 2. It's going to get stretched 2 units left and 2 units right from the center. And then the b value, that's technically b squared. So what's b? 1. So it's going to get stretched vertically, up 1, down 1. And here's your ellipse. Because this is, look at your structure. The bigger number is a squared. So 4 equals your a squared, which means a is 2. I took the square root, yep. And they'll usually be pretty nice numbers. You're not going to have to go up like 5 root 2. That would be pretty nasty. I would say, I don't know how I would say. We don't really talk total transformations. I would say it's stretched 2 to the left, 2 to the right. It's stretched outward by 2, I guess I would say. It could be they tend to put the bigger number first, but truthfully it's addition. So if it was in an opposite order, it's not really going to make a difference. A is just the bigger one, and that's the way it's stretched more along whatever axis that is, which in this case was x. Good? Okay? And so b was 1, or b squared was 1 if we want to document that work, which made b 1. So there's your picture, which is fairly straightforward. Yes? The vertices are these 2 points. They're the longer endpoints, right? If it was a vertical ellipse, these would be your vertices. If it's a horizontal ellipse, these are your vertices. Do we follow? Okay, so our vertices are just the coordinates of those points. 1, 2, and 1, 2, 3, 4, 5, 2. So your focus points is where we have to do a little work because we don't have those graphed yet, right? They're somewhere in here and here. But we get those by, remember C, up from above? C is our, where's C? C is our distance from the center to the focus. So with A and B, and you have to know this equation, it's not the Pythagorean theorem. It's A squared equals b squared plus c squared. So a squared was 4, b squared was 1, and we just essentially have to find c. So I'm going to subtract 1 from both sides. C squared equals 3. And then c is going to equal, if I square root that, c is going to equal plus or minus root 3. So here's the deal. To get to my focus then, I start at my center, I have to go root 3 units over to the right and root 3 units over to the left. So if I look at this point whose coordinates were 3, 2, if I go root 3 units to the right, what is that coordinate? You're not going to get the actual number. You're just going to take what the x coordinate was, 3, and add root 3 to it. That's your new x coordinate. And your y coordinate is still 2. We've just shifted that over to the right root 3 units, and we're going to do the same thing and shift it over to the left 3 units. So 3 minus root 3, but still a y coordinate of 2. That's probably the hardest thing because it doesn't just show up automatically. You actually have to calculate it using this a squared equals b squared plus c squared. Yes. We don't, I mean, if you wanted to be more exact, where's 3 minus root 3? I probably don't have it in the right spot. It's probably pulled over more. 1.26. So yeah, it's a little bit further over in real life. But those are like the balancing points. Like two. Like if you had like a 2D picture of an ellipse in front of you and you could balance, you had to balance it with two fingers, you'd be putting them at the focus points, and that's how it would balance on your two fingers. Does that make sense? So foci, endpoints of the minor axis, those would be the top and bottom here. Here's your minor axis. Here's your major axis. Yes? Endpoints of the minor axis are just, let's see, 3, 3 and 3, 1. The latus rectum is the chord perpendicular to the major axis, so that would be right here. It's really the length of your minor axis, which is how many units long? 2, right? I'm going to double check this. Something doesn't see that. I don't know why she's asking that twice. And then the length of the major axis is 1, 2, 3, 4. Yeah, I know. I still think that definition matches and is the same thing as the minor axis, but it's probably not. So I have to look further into that one. So we'll stop there. I won't give you homework tonight. We'll pick up with this tomorrow. You did. By getting 0 points off on the front of your test. You've already repaid me. This is the, now